Join us for the 2025 n-Lorem Nano-Rare Patient Colloquium, hosted by Biogen, this October 20th and 21st in Cambridge, Massachusetts. Connect with members of the Nano-Rare community as we explore the latest from the Foundation, share insights from treated patients, feature expert-led panel discussions, and more. Supporters, physicians, scientists, and patients and their families will come together for 2 inspiring days of learning, connection, and hope. Don't miss it. Register now to attend in person or virtually at n-Lorem.org.
This episode of the n-Lorem Patient Empowerment Program podcast is proudly sponsored by Hongene Biotech. With more than 26 years of experience in the nucleic acid industry, Hongene is a specialized CDMO and raw material supplier committed to providing high-quality and high-value products and services with the best-in-class lead times.
Hello and welcome to the n-Lorem podcast series, a series that focuses exclusively on patients now referred to as having nano-rare mutations. I'm Stan Crook, and I'm the founder, chairman, and CEO of n-Lorem. n-Lorem is a nonprofit foundation that I initiated in January of 2020. Our mission at n-Lorem is to take advantage of the technology we created at Ionis Pharmaceuticals, Antisense technology, or ASO technology, to discover, develop, and provide experimental ASO treatments to nano-rare patients, and to do that for free for life. Today, we'll be talking about a topic that I think is extraordinarily important, and we have a lot of good news to report. What I will be sharing with you is new insights into genetically caused developmental delays. At the molecular level, development is a carefully orchestrated process that begins in utero and extends for years beyond birth, and timing is critical. So if an enzyme is needed to take a particular step in development and it's not made on time, even if that enzyme becomes available later, that development step that required the enzyme typically doesn't happen. For this and many other reasons, I was taught that if a step in development is missed or delayed, development will not be normal. And once a developmental delay occurs, that defect is permanent. One of the most important conclusions from the work that we've done is that development deficits are not permanent unless they produce structural damage such as microcephaly or congenital deformities of the skull or bones, or something like scoliosis that may come from abnormal muscle function. Short of that, in fact, we now know that the CNS is far more resilient, far more plastic than was believed even 5 years ago. And this is great news. In this podcast, I plan to tell you how we've learned this, cite a few examples, and summarize the implications of our findings for you. The observations that support our conclusions are actually many. And to some extent, one of the real deficiencies of treatment of nano-rare patients has, in an odd way, facilitated our learning some of these lessons. Because today, nano-rare patients, the diagnosis of nano-rare patients is very slow. The average time from symptom onset to diagnosis in our patients is about 5 years. And during that time, the disease progresses. And so most of our patients to date that we've treated have diseases that are extremely advanced, very advanced. And most of our patients who had diseases expressed in infancy have suffered broad-scale, profound developmental delays. And so when we begin treating a patient with an advanced disease that began in infancy, we are dealing with a patient who has developmental delays that have had decades to accumulate, years to decades to accumulate. And so we've now treated many of these patients who were severely affected as infants, suffered from severe symptoms, and never developed many skills or lost skills that they acquired as the disease progressed. Our experience includes patients with many types of mutations in a wide range of genes that affect many functions and result in a multiplicity of symptoms. So while we want to begin treatment earlier, the fact that we have treated so many patients with advanced genetic diseases in the CNS with such diverse symptoms and developmental delays has generated data that compellingly demonstrate that there are vastly fewer limitations in the benefit that ASO treatment can bring than we thought before. And in many of these, it's easy to say that the benefit is nothing short of miraculous. So what I want to do now is just summarize some important examples that will help you understand why we can say this, how confident we are when we say this, and also what we don't know and what we hope to learn in the next few years. So let's break developmental delays. And one could argue some of these may not be, strictly speaking, developmental delays, but they're all problems that our patients have that accrue over time as they attempt to develop and fail. So one of the areas of movement developmental delays and problems for patients is movement disorders. And you can break those movement disorders down into two broad groups. The first is just loss of the ability to move muscles. And that can happen either because of neurological problems or muscle problems or both. And so arguably the loss of muscle tone is the simplest symptom complex that we deal with. And it is the progressive loss of the ability to actually make your muscles move that we're talking about. Good examples of this symptom complex are Parkinson's disease, ALS, and SMA. Such symptoms can manifest during infancy and progress, such as we observed with type 1 SMA. Alternatively, the symptoms can become apparent much later, as is the case with ALS and Parkinson's disease. Typically, the last muscle group to be affected is the respiratory muscles in the chest and the diaphragm, and patients succumb because of respiratory failure and respiratory infections. We now have substantial experience in ASO treatment of disorders like SMA and ALS, and our data convincingly demonstrate that ASO treatment can dramatically enhance muscle strength and produce prolonged, profound benefit. Moreover, we've treated patients with very advanced diseases, even if they have been bedfast and required ventilatory support. In SMA patients, we've conclusively shown that if we treat pre-symptomatically, we can prevent the disease from manifesting at all, suggesting that if we were to treat these motor diseases earlier, we could do even better. So that's a lot of good news. Now, the other type of movement disorder is abnormal movements or the ability to control movement. Often, n-Lorem mutations occur in genes that are involved in initiating, controlling voluntary movement. Though we take this for granted, if you think about it for just a minute, it's astonishing all that has to happen to make what we take for granted work. For example, think about using your hand to type. To do that, you have to first visualize what you want to accomplish in your frontal cortex. And the frontal cortex then has to send an electrochemical signal to your motor cortex, telling the motor cortex what to do. Then the motor cortex has to send signals to the muscles that it wants to contract and the counter muscles that it needs to relax. So in one case, it's sending a stimulate, okay, let's flex our muscles. And in the other case, it's saying, no, we have to relax. All that has to happen at the same time and be perfectly timed for you to move your finger, your hand, to type on your keypad. So to me, the ability that we can do the things we do constantly amazes. And I ask you just to think about the idea of moving your hands, your arm. Think about the challenge of standing up. You're sitting down and you stand up. And so if you stand up real fast, sometimes you get dizzy, right? That's because your blood pressure has to be changed very rapidly to take care of the fact that you're standing instead of no longer sitting. And what causes you to be dizzy is your blood pressure drops, you no longer can handle the signals in your brain, and you can fall down. So just think a minute about how amazing you actually are. Okay, so many genes and families are involved in this complex process of controlled movements. But a good example is ion channel genes. You are an electrical machine, and to generate and control electrical impulses, you need to have many types of ion channels. Mutations in ion channels can often cause abnormal ballistic muscle movements called chorioathetotic movements. Choreo meaning uncontrolled spastic movements, and athetotic meaning sort of slow writhing movements. And you see these patients who have both, which is extremely disabling. Now, we've treated now a number of patients with severe movement disorders caused by ion channels with great success. Connor, a 15-year-old boy with a mutation in a sodium channel gene, SCN, who had never walked independently in his life, is now walking independently because of ASO treatment. Many other patients also suffer from severe tremors. And while many of us may have some minor tremor, really significant tremors are highly disabling. There's just simply things you can't do if your hand shakes. And here, too, we've observed remarkable benefit. So both the loss of the ability to move at all and the loss of the ability to move with control are amenable, no matter how advanced, to benefit from ASOs, and essentially irrespective of the type of mutation or the type of gene involved, based on what we know today. Issue that our patients experience is seizures. Now, you can say that seizures aren't exactly developmental delays, and maybe that's true, but seizures are debilitating. And they lead to further developmental delays because of the damage done, the electrical damage done when you seize. And of course, many of our patients have mutations that cause severe seizures that are dangerous, and those cause severe developmental delays. And we've shown that we can control the most severe constellations of seizures in patients with very advanced diseases with mutations in a wide range of genes. Subsequently, they can recover functions that they either never acquired or lost. We also have changed the character of mutations, and we moved mutations from less frequent to also less severe. And so these are remarkable changes that we're observing that protect brains, free patients, and open doors for those patients to recover functions and gain new functions and prevent further damage to their brain. Really important stuff. Another problem that our patients have that you might not think of as strictly developmental delay is ataxia. Ataxia, or dizziness, can be very severe. And if it's severe, obviously you're going to be debilitated. You can't stand if you are dizzy. I'm sure you've gone in circles as a kid and fell over because of your dizziness. That was ataxia at work. Imagine if you had that every minute of every day. So we now have shown that if you have severe ataxia, almost irrespective of the gene that we've treated, we can make you better. Susanna, who has a KIF1A mutation, is a good example of a patient with such advanced disease that she was wheelchair-bound, both because of her inability to control her muscles and dizziness or ataxia. With ASO treatment, she regained the ability to walk, to catch a ball, to play basketball. These are remarkable observations. Tayson, think about Tayson. He's a 19-year-old boy with a CAG repeat in the ATN1 gene. He had lost the ability to walk independently, but with treatment, he regained that ability and regained sufficient muscle control that he could catch a ball and put his shoes and socks on. That may sound trivial to you. That's a big deal if you can't do it. And not only does it change his symptoms, it changes his life. He becomes more independent. He can dress himself. He can do things that he couldn't do before. Remarkable. Cognition. Intellectual disability is a common feature of nanorare mutations and can be caused by mutations in many different genes. Once again, we have multiple examples of improved cognition in patients with diverse mutations in diverse genes and diverse types of intellectual disability. Not simply basic stuff, but much more complicated, integrative intellectual activities that require a really fully functioning brain. Many of our patients have mutations in genes that cause them to lose their ability to speak, to be logical, to speak clearly, or to speak at all. And again, multiple patients demonstrating recovery of speech. Susanna, our KIF1A patient, our first KIF1A patient, basically a very verbal young girl who by the age of 9 was basically unable to speak more than a word or two, sang the national anthem at a sporting attraction on treatment. Autistic symptoms. Many of the mutations in many of the genes that our patients have generate autistic symptoms, and that includes both intellectual disability and other manifestations, and they tend to worsen with time. And so in addition to intellectual disability, the symptoms often include repetitive, obsessive-compulsive behaviors, irritability, anxiety, self-destructive behaviors, and the inability to relate to others. We have many documented examples of significant benefit in all of these symptoms as well. Severe neuropathic pain or pain syndromes. You might not think of these as developmental delays, and maybe they're not, but they do and they make development much harder. It's hard to develop if you're writhing in pain constantly. It's also hard to develop if you can't feel pain and you mutilate yourself, you burn yourself, you do things like that. And we have patients with both types of pain problems, and both have benefited. I do want to just, while we're on it, add autonomic dysfunction to our list here. Autonomic dysfunction is not formally a developmental delay, but the autonomic nervous system is the most primitive part of your brain. It controls things like blood pressure, heart rate, respiration rate, your gut movement and control of your gut, your control of your bladder and your ability to urinate. You take all that stuff for granted, but there's a whole system that's working behind the scenes without you having to think about it that lets you do those things. And if you can't, you wear diapers. If you can't stand up. If you can't, you have high blood pressure or abnormal heart rates, and any of those things can kill you. So not strictly speaking a developmental delay, but broadly speaking, debilitating and when present, make developmental processes impossible. Once again, for the first time, we have shown that an ASO can help autonomic dysfunction. And I should add that our demonstration of improved pain syndromes is a first for ASOs. It's never been done before. So not only are we learning about health and disease and helping patients, we're also learning about the technology and advancing our knowledge about technology and how we can use it more broadly to help more people. So what are the implications of all this? Well, I've just given you great news. I can't think of a more optimistic presentation I've ever made in my life, and a more surprisingly optimistic presentation. These observations change and the way I think. They're changing the way we in the scientific and medical community think about the brain, how we think about developmental delays, and how we approach patients with very advanced disease. No one can say anymore that there's no need to make a diagnosis because the patient doesn't have any treatment. No one can say anymore that a patient is too advanced to be treated. No one can say those things because of the work at n-Lorem. That's a lot, and we are proud of it. But most importantly, what we've learned opens new vistas in therapeutics and encourages us to do more. They encourage our patients to hope more and to dream bigger. And as we present our results to payers, I'm hopeful that they will see how economically advantageous to them it would be to introduce genomic sequencing into all newborn patients and to support ASO treatments, even if they're not formally approved by the FDA. And that's all wonderful. I also have to say that knowing what's possible today frustrates me greatly because I know how much more we could do if we had more funding. And that, in turn, encourages me to work even harder on behalf of non-rare patients. And I have to say to you, no one who cares should be sitting on the sideline. Everyone who cares should be helping us do this, and at the minimum, contributing what you can afford. We need your support. We've only done what we've done because of the great support that we've gotten, but the demand continues to grow exponentially and the money. So help us do this. We need your support. Thank you.
n-Lorem is a nonprofit committed to discovering and providing personalized experimental treatments for free, for life, to patients with genetic diseases that affect 1 to 30 patients worldwide, referred to by n-Lorem as nano-rare. Many of these patients progress and die without ever achieving a diagnosis. This is where n-Lorem comes in. They do the impossible by providing hope, and for those that they can help, free lifetime treatment. For more information about n-Lorem or today's episode, visit n-Lorem.org. Any questions can be sent into podcast@n-Lorem.org. Search n-Lorem on Twitter, Instagram, YouTube, LinkedIn, and Facebook to connect with us. Please rate and review the podcast on Apple, Spotify, or wherever you listen. This truly helps us climb the charts and allows others to find the show. This podcast is hosted by Dr. Stan Crook. Our videographer is John Magnuson of Mighty One Productions. Our producers are John Magnuson and Kira Deneen of DNA Today. Thank you for listening.